For part A, we need to determine the average acceleration for 0 to 3 seconds. So let me go ahead and highlight the information from the question. It's initially at rest, that's important. That's the starting velocity. And it reaches 95 kilometers per hour at the 3 second mark. Okay, so there's the information we need. I'm going to list that out. So V1 will be 0 because it's at rest at the start. V2 will be 95 kilometers per hour. And the time, delta t, well, it's from 0 to 3 seconds, so that's going to be a time of 3.0 seconds. So the first thing I'm going to do is do some kind of a unit conversion so that the units are matching for everything in my given list here. I've got kilometers and hours and meters and seconds. So you want that all to be consistent. So I think the easiest thing to do in this situation is to convert the 95 kilometers per hour into meters per second. So the shortcut way to do that would be to divide by a conversion factor of 3.6. If you don't know that kind of shortcut, then I guess you kind of just do it the long way, think it through. You can ask Siri to do it or go on Google and get Google to convert it. But at the end of the day, you're going to need to come up with 26.38 repeated meters per second. So to get this acceleration, I just find the formula I need, the one that's got V1, V2, time, and acceleration in it. And that formula looks like this. The initial velocity is 0, so I'm just going to cross that off from the formula. 0. And now I go ahead and substitute the values. So 26.38 repeated. It's meters per second over 3.0 seconds. Get that in my calculator. And that's going to be going to 2 sig figs. So that's going to round to 8.8. The units of acceleration, so I've got meters per second in my numerator, seconds in my denominator. So that's going to end up being meters per second squared. All right, part B, the distance the cheetah covers from 0 to 3 seconds. So it's the same given information. The V1, the V2, and the time are all the same because we're still dealing with the first 3 seconds here. But now I have to find the distance. By the way, I'm using like these formulas which are normally with vectors, but I'm kind of putting scalars into them. That's because I'm just assuming this cheetah is going in a straight line here. So it's just going forward, so direction does not really make a big difference here. All right, so I need the formula that's got the displacement and the V1 and the V2 and the time. So that formula looks like this. So these are all formulas on the formula sheet. You just got to find the one that applies to the situation. Again, the V1 is 0. So now I'll just plug in the values. This is multiplication, so again we're going by sig figs, and it's going to be 2 sig figs. I'm going to have to round this to. And I'm getting 39.6. I'm just going to underline the first 2 significant figures. But I'm keeping an extra digit here because I'm just looking ahead at part C, because I may have to use this number I just got. So I want to keep some extra digits there. Part C, determine the distance the cheetah covers from 0 to 10 seconds. So the answer to B is the first 3 seconds. So now I've got to figure out how far the cheetah goes in the next 7 seconds, and then add that, and that'll give me the overall distance for the entire 10 seconds. So it says for the next 7 seconds, it maintains that speed, whatever speed it left off at. So that would be 95 kilometers per hour, or 26.38 repeated meters per second. So I'm just going to start a new list here. So the speed, 26.38 repeated meters per second. The delta t, I'm going to do this for a 7-second interval. And I'm trying to find the distance. I'm going to add a heading here, actually. The heading for what I'm calculating right now is the distance for the interval from 3 to 10 seconds. Okay, so right now I'm finding the distance for those final 7 seconds. I'm going to add that to the answer from part B, which was for the first 3 seconds. Okay, so going back to the green section, how do I find this distance? This is just a speed equals distance over time question, where I rearrange the formula to get distance. So I'm not going to talk through all that, just it's going to end up being speed times time equals the distance. Substitute the values. Put that in the calculator. Giving me 184.7, which would be to 2 sig figs. So to get the total distance, so I'll have a new heading here from 0 to 10 seconds. Give myself some more room here. The total distance, I just added up. So my answer from B, which was 39.6, plus this answer here of 184.7. And since I'm adding, I got to go by decimal places. And it looks like I have to go to the nearest tens column. The nearest tens column, because of the 184, that only goes up to the tens column. All right, I'm gonna just throw this in the calculator. I'm kind of tired today. Normally I could do that in my head. But that's 224, but rounding it to the nearest tens column. I'll have to go into scientific notation here 2.2 times 10 to the 2 meters.